So now we're going to talk about expected value. Expected value is basically an average. When we talk about an average, we have the summation of all the observations divided by n. But when we talk about expected value, they're not all exactly equal to each other. So instead of dividing everything by n, we can move that. You know what? Let me put it back. Take this n, and we're going to move it over to the side. And we'll take that n, and instead of doing it all the same, we could do the same thing as saying 1 over n and multiply them all together, or by the fraction of. I'm just moving the denominator out to the side. But this isn't always this exact same thing, because sometimes we have different weights. There's different probabilities of something happening. And so we can't really multiply it by n or divide by n, but we have to multiply each observation, x sub I, by the probability that x sub I will occur. And here we're going to calculate that probability by adding them up. And so here we're going to pretend for a second that in the previous 100 days, 10 times, on 10 days you have sold 0 cars. And 25 days you have sold 1 car, 30 days you have sold 2 cars, and that means that that's what, 30, 55, 65, and 35 days you have sold 3 cars, right? So the probability, this is the days that you have sold these, so the probability of any one of these occurring is just a fraction of the total. I add all of these up and I get a total of 100 days. So 10 divided by 100 is 0.10, 0.25, 0.30, and 0.35. So the probabilities of any one of these happening, the probability that tomorrow when you go to work to sell a car and you're going to sell 0, the probability of selling 0 is 10%. So we now can do this average where the weights of these averages are not exactly the same. All right. And how would we do that? Well, we do the summation of all of these things multiplied together. So that's going to be the summation of x sub 1, that's 0 times 0.1 plus 1 times 0.25, right? And all I'm doing here is I'm taking this guy and I'm multiplying it by this guy. And then I'm taking this guy and I'm multiplying it by this guy. That's x and the probability of x, or x sub, in this case that's x sub 2, times the probability of x sub 2. All right, so that's going to be plus 2 times 0.30 plus 3 times 0.35, and so on. And so you add these together. This one obviously equals 0. This is obviously 0.25. 2 times 0.3 is 0.6. And 3 times 0.35 is what? 905. 105 plus 1.05. Let's double check that. Where's my calculator? Just to keep you guys happy. 3 times 0.35 equals 1.05. Excellent. All right, and so we add these guys together, and that's going to be 0.25 plus 0.6 is 0.85 plus 1.05, and so our total here should be what? 1.90. So the expected value, the E of x, which we can also describe as the weighted average, is equals to 1.90 cars. What does that really mean? As a future manager, as a future car sales manager, you can do this for almost any business environment. You should have the expectation that your sales team, or in this case yourself, that you should sell on average 1.9 cars per day. That's all that expected average really is. And so let's go over that again one more time. When I calculate a regular average, I have the summation of all my observations divided by n. But in this case, those weights of probabilities are going to be a little different. So the n has to go away, and I have to multiply each x by the probability that x will occur. And then we just get the summation. So in this case, we do x sub 1 times the probability of x sub 1, x sub 2 times the probability of x sub 2, and so on and so forth. Another easy way to do this, as long as we're up here, let me get another color. How about green? Another way to do this is to just multiply across here. 0 times 0.10 is 0. Let me rewrite this so you guys can see what I'm talking about. I'm going to make this x sub I times the probability of x sub I. So that one's 0. 1 times 7 is 0.25. 2 times 0.30 is 0.60. And this guy times 0.35 is 1.05. And then I can just do the summation. I can do it up and down. It might even be easier if you do it this way. 1 plus 2 is 3, plus 6 is 9, and then the 1.90. And this is my expected value. And so that's basically it. If we were to do this as a variance, or let's do a variance equation real quick, or a standard deviation for the expected value, then we would still have 0, 1, 2, and 3 with the probabilities the same, 1.25, 0.30, 0.35. And so our variance equation is the summation of x sub 1 minus mu squared. And again, instead of dividing by the n, I'm going to multiply all of this by the probability that x will occur on the side. And I have that right here. This is the probability of x right there. So let's do that. Let's take my mu. And what is my mu? In this case, the mu's already been calculated as the expected value of x, right? So that's 1.90. So we just subtract one from the other. So let me write it down. 1.9, 1.9, 1.9, 1.9. I'm going to need this space in a minute. 0 minus 1.9, so x sub 1 minus mu, is negative 1.9. 1 minus 1.9 is negative 0.9. 2 minus 1.9 is equal to 0.1. And 3 minus 1.9 is equal to 1.1. What do I do next? I take this number, x sub 1 minus x sub I minus mu, and I square it. So let me pull out my trusty calculator. 1.9 squared is equal to 3.61. 0.9 squared is 0.81. 0.1 is times 0.1 is 0.01. 1.1 is 1.2, 1.21. Let me double check that. 1.1 times 1.1, 1.21. Excellent. All right, and then I do the exact same thing. I add them. No, I don't add them. I don't add them yet. I have to multiply them by their probabilities now. Okay, before I add them, I wonder if yellow will work. Now I have to take advantage of the probabilities because I'm not going to divide by n. I've got to do this one now, right, and go across. So I'm going to do that times the probability of x sub 1. All right, so 3.61 times 0.1 equals, obviously, 0.361. 0.81 times the probability of that particular observation is 0.20. 0.01 times 0.3 is equal to 0.003. And finally, 1.21 times 0.35 is equal to 0.42. If I add these guys up, I get, let me chop this guy off. I'm going to just put 0.0 and make that go away. 6 plus 2 is 8. 3 and 5 is 2, and 4 is 9. I get 0.98. 0.98 then is my variance. And if I want the square root, the standard deviation, which is the square root of my variance, then what I have to do is take the square root of 0.98, which should be about 0.9. 0.98 square root is 0.989, which is equal to 0.989. It's about the same thing. the standard deviation. Note that there is a slight modification to this equation. Let me write it down again. The variance, when we have an expected value, is equal to the summation of the observation minus the average squared times the probability of x. Put that closer over here so you can see it. Times the probability of x. Note that there's no divided by n. Okay? There's none of this. This isn't here. Right? We're going to erase all of that because instead of dividing by that n, we multiply by the p of x on the side. And the same thing is true for our basic expected value calculation. We have the summation of x of I over n for regular average, but this is wrong. When we do expected value, we have to multiply this guy times the probability that any one of the observations will occur, because the probabilities are not uniform. They are different for each observation. I hope that helps, and good luck.